Alright, good afternoon, Year 6. Welcome back to Mr. Chan's Math Corner. Now today we're going to talk about prime factorization and how to find the HCF and LCM. Now earlier we should have talked about the using factor trees and short division. Okay. Now one of you guys asked me, why do we need to use this? Why do we need to learn how to do this? Okay, or prime factorization, why do we need to know? Well, one of the ways is this is the fastest way to find the HCF and LCM. Okay, so first of all, in your booklet, which is right here, if you go to page 13, and you will find some information on the top. Okay, now it says one of the two statements there that has HCF, says product of the smallest power of each common factor. And then LCM, it says product of greatest power of each prime factor. Okay? So if you read it without the teacher telling you what it means, you probably don't know what it means, right? Okay? So let's take a look. I have two numbers. One is 150 and one is 980. Now I did the short division and factor tree on the side, and I so happened to find out that the prime factors of 150 is 2 times 3 times 5 to the second power. And then the 980, after I did all the prime factor trees, I found that it was 2 squared, or to the second power, times 5 times 7 to the second power. Notice how I lined it up. I lined up the 2, the 3, the 980 doesn't have a 3, so I leave it blank. And then I have a 5, so I line up with the 5. And then there's a 7 for 980, but 150 doesn't have a 7, so it doesn't matter as long as you line it up properly according to the numbers or different factors. Okay, that would make everything easy. Now, can you say, do I have to line it up? You don't really have to, but I'm telling you this is the easier way. Alright, so HCF. Let's try to find the HCF based on this definition. Okay, if you look at it in black, you will see the product of the smallest power of each common factor. Okay, notice this right here, common factor. So let's look for the common factors. HCF, common factors, 2 and 2. Is that in common? Yes, I bring it down. Okay, any more? 3. Is it in common? Nope. This one has, this one doesn't, so I can't bring that down. This one has, this one 5. Yeah. Okay, so that's a common factor. Okay. 7, only the bottom has, or the 980 has a 7, but the 150 doesn't. So the only common factor I have is 2 and 5. Okay. Now, then I need to, according to the description, the product of the smallest power of each common factor. So let's compare. Smallest power, that one has 1, that one has 2, so I would pick the smallest power. In this case is 1, but 1 I don't really need to write. And then same thing, the 5, I also pick the smaller power, which is also 1, then I don't need to write it. So this HCF is actually 2 times 5. Okay? Now, if it, make sure you read the instruction carefully. If the instruction says, leave it as product of the prime, then I'm done. Okay? Now, if it says exact numbers, okay, exact numbers, then you have to multiply it out. In this case, you would have 10. Okay? Alright? So, how about the second part? LCM, let's change the color. Purple. LCM, it says product of greatest power of each prime factor. Did it say common? It says each. Okay, each prime factor. So I don't need to compare the common factor. As a matter of fact, if there's a factor there, I'm going to use it as my LCM. So 2, I'm going to use it, okay, times, let's see, 3. Remember, we do not need to have common factor. So 3 is a factor, I bring it down. Even though this is not common, only one of the number has it, I bring it down anyway. 5, okay. And then finally the 7, okay, times 7. Alright? So, now, we're not done. We're looking for the product of greatest power. Alright? So, of the two, I need to choose the one that has greatest power. The 2 has the greatest power, so I put a 2. The 3, there's only one that has a 3. 5, there are 2 of them. I picked the greater power, which is 2. And the 7, there's no comparison. That is only one that has a 2. Okay? So again, if the problem says, look for the LCM, find the LCM with the using product of the prime, then you are done. Okay? If it says exact number, then you actually have to multiply everything out. Okay? In this case, 14700. And that would be the exact number, okay? If the question's asking for the exact number. If asking for product of the prime, this is what you would have. Okay? Alright? Good. Any question, please ask your teachers.